In our last two examples, we did a graph of f of x equals 3 to the x power. This is what we got. It was exponential growth. Then we did the graph of f of x equals 3 to the negative x power, or f of x equals 1/3 to the x power, and that was exponential decay. The thing that makes it exponential decay is whenever your base here is greater than 0 but less than 1. That's when you're going to have this graph be an exponential decay graph as opposed to exponential growth. Notice that with both of these graphs, I can draw a horizontal line anywhere that I want, and it's only going to cross my graph at one place. So because of that, this is what's called a one-to-one function. All of your exponential functions are one-to-one functions. They pass the horizontal line test. If you made a table of values, no y values would repeat. Which brings us to our one-to-one property, which basically states that if a to the x power equals a to the y power, then we know that our exponents are the same. X is equal to y. Let me give a quick little example here. If I had, let's say, 2 to some power equals 8, there is only one value that will work for x here, and that is 2 to the third power. So what's going to happen is I'm going to have an equation, and I'm going to notice that I have quantity on the left and a quantity on the right. At least one of these will be written in exponential form. And my goal here is going to be to write both the left and the right-hand side so that they have the same base, so that I can use this one-to-one property and basically wipe out my bases and just have, okay, whatever exponent I have here has to be the same as the exponent over here. Let's do an example. So let's say I have the equation 3 to the x plus 1 power equals 27. So my hint here is that I want to set it up so that both sides of the equation have the same base in order to use the one-to-one property. So how do I write the number 27 so that it has a base of 3? Well, it'd be 3 to the third power would equal 27. Now notice that both my left and my right-hand side have the same base of 3. The only way that these two quantities are going to equal each other is if this exponent is the same as this exponent. So I'm going to set x plus 1 equal to 3. I'm going to solve, and I get that x is 2. And notice that if you substitute that in, the math works out. 3 to the 2 plus 1 power equals 27. 2 plus 1 is 3. 3 to the third does in fact equal 27.